Yeah, a simple question to get polarity for mole fraction. It says calculate the molarity of a solution of NaCl with mole fraction of 0.1. Yes. Now, usually most NaCl solutions should be noted that most NaCl solutions are aqueous. So most of NaCl solutions are actually aqueous. So how do you get mole fraction from an aqueous solution? So how do you get molarity from an aqueous solution of NaCl with the mole fraction of NaCl 0.1? So first of all, the mole fraction of NaCl, the mole fraction of NaCl is equals to 0.1. Now, it means that the mole fraction of the solvent, which is most likely to be water, is is actually 1 minus 0.1, which should be 0.9. So the mole fraction of a solvent in a mixture of its solute and the solvent is 1 minus the mole fraction of the solute. So as simple as that. So since we have the mole fraction of the solute, we assume that the total mole is 10. We assume, okay, so let me just put it here. Assume total mole is 10. So if total mole is 10 and the total mole is 10 mole, yes, 10 mole. If total mole is 10 mole and the mole fraction of NaCl is 10, it means that the number of mole of NaCl, is going to be fraction is like a percentage. The fraction is going to be 0.1 times 10, which is 1 mole. Then the mole of H2O will be 0.1 times, of H2 0.9 times 10, which is 9 moles. So we get their various moles like that. So the molarity of 10 mole of solution with mole fraction of 0.1 is still the molarity of 100 mole of NaCl solution with mole fraction of 0. In as much as the mole fraction is constant, the molarity is constant. So we can just assume a given mole. So we can just assume a given mole and we solve. So first of all, having assumed that the mole is 1 and 9, so the mole can be 10 and 90. The mole can be, depending on your figure, the mole can still be 0.1, 0.9. So just assume that the total mole is 1. The 0.1 of 1 is 0.1, 0.9 of 1 is so the mole fraction of in as much as the mole fraction is constant, as I said before, the molarity is constant. So we should know that. So I haven't gotten that. I haven't gotten the mole. I've assumed the mole total mole is 10. So I want to try and get the molarity. So first of all, I need the mass of NaCl for that 10 mole. So for that 10 mole of the solution, the NaCl mass, remember, number of mole is equals to mass over molar mass. So the mass of NaCl should be needed in order to get molarity. Okay. I might not really need the mass of NaCl because molarity says that molarity is number of mole over volume of solution. Yes, number of mole over volume of solution. So I don't really need the mole of NaCl. So the mole of NaCl, I will not need the mass of NaCl, pardon, I will need the mass of water in order for us to get the volume. So for water, the number of mole of water is mass over molar mass. The mass of water is unknown. Um, um, the mass over molar mass W. The molar mass of water is 18. So the number of mole of water is 9. So therefore we can see that the mass is equals to 9 times 18. So mass of water is equals to 9 times 18. So getting the mass of water, I should have 9 times 18, which is 162. So the mass of water is therefore 162 grams in 10 moles. In 10 mole. So if it's 162 grams in 10 moles, I can now get molarity. Now, recall, should be recalled that the density of water is 1 gram per milliliter. Now, what does that statement mean? It means that for every gram of water, statement means that for every gram of water, there is a single mil of water. Let me write this word so you see it. So this statement, okay, this statement means that for every gram of water, there's 1 mil of water. That means this 162 gram can be 162 mil of water. So Haven't gotten this. So this can be for water. Remember, this is the mass of water. So let me just write it. So mass of water. Okay. So I haven't gotten this. We can now assume that the volume of water is 162. And for solutions, in order to get the molarity, especially aqueous solutions, solutions in water, the the volume of water is most cases the volume of the solution. Now assume this: when you put a small amount of salt in water, does the volume actually change? The volume does not really appreciably change. It's just the volume just is increased by a tiny fraction. So usually the volume of water for aqueous solution usually the volume of is usually the volume of the solution. So it's like adding a 0.1 mole of NaCl, a very small amount of NaCl to 9 mole of water. The volume may not really change. So we can assume that the volume of water is equal to the volume of the solution. So if I should write it here, so volume of water, if you are following this my calculation, volume of water is equals to 162 mil from the mass because the density is 1 gram per mil. So since there's 162 gram of water, there's 162 mil of water. Using our molarity formula, which says, right, should remember your molarity formula which says 1000 times mass of solute over molar mass, which is W, times volume of solution. It should be noted that these two are for solute, mass of solute, volume, molar mass of solute. So mass over molar mass is number of mole. I can rewrite this formula. Hope you're following. If you're not following, I'm just scroll back a little. It's simple, self-explanatory. So I can rewrite this formula and say, that molarity is equal to 1000 times number of moles of solute over volume. Now, the volume is in mil because of the 1000. So if here was not 1000, the volume should have been in liters or dm cube. Here it's in milliliters. So, imputing our parameters, I have the number of mole of solute. The number of mole of solute is 1. So molarity is therefore equals to, what's molarity? Molarity is therefore equals to 1000 times the number of mole is 1. In 10, assume 10 mole. Then 162 is the volume of the solution, volume of water. So when solving for molarity, especially in aqueous solution, when the volume of the aqueous solution is not given, use the volume of water as the volume of the aqueous solution. So what therefore is our molarity? Our molarity would therefore be 1000 times 1 divided by 162. So that should be 6.17. 6.17. So our molarity is going to be 6.173 molar or mole per dm cube. So I recall, what did I do? What did I do again? So I assume that the total mole is 10. I can assume that the total mole is 1. Or if you are confused, just assume that since the mole fraction of NaCl is 0.1, just take the mole of NaCl to be 0.1 and take the mole of the solvent as 0.9. You can also work with that. Then what you do is that because it's NaCl, the solution usually in water. So this question can be of an aqueous solution, or this question is supposedly to be of an